Kia ora. Welcome to Is There an Ocean in the House? I'm Steve. In normal times I would be working at the New Zealand Marine Studies Centre, University of Otago, Marine Science. We're going to be investigating a whole aspect of ocean that defines the planet and defines us. Each investigation is around one topic that helps characterise that ocean of the world. There'll be material that you can access online that supports this, links to other pieces of information, and where we can share more experiences about these particular aspects. And also, these videos, which will be benchtop activities, and you can do ocean science without you leaving home and without me going to sea. So, let's get on with it together. Is there an ocean in the house? And this is going to be our lab. Hi, here I am at my gate, and I'm lucky enough to have the sea as my front yard. The first thing that strikes you about the ocean is its sheer expanse, the size of it. Moana Nui. Moana Waiwai, the open sea, is out past there. And when you get down to it, when you come down to the sea, the first thing that you notice as you come down to it is the taste of it. You get, yeah, that saltiness. Now there's one ocean, but there are many different seas, differentiated by their history and their location, defined by boundaries, separate but one, like us. And as we go and explore this further, we're going to be looking into those differences between those different seas. For example, here in this estuary, it might mix with the fresh water and be a salinity of something like 10, 15 parts per thousand. Out in the open sea, 35 parts per thousand. On the shore, in a pool, when it evaporates, 55 parts per thousand. And deep down in the Red Sea, 100 parts per thousand. Okay, let's head back into the lab now and explore this further. Here we are, back in our lab. First of all, there's going to be two procedures here, and for this we're going to need this little kit here. Just the old kitchen scales, probably measures within plus or minus 1 gram. A measuring jug, hopefully up to a litre. Cup, spoons as you can see, dessert and teaspoon. Bit of salt, probably got, and 1 2-litre ice cream container. You might have to go to the freezer and finish that ice cream off to get that one. And some empty containers. These aren't empty yet, they've just got water in them. Could be just a milk container, any old containers. You need probably 5 or 6 of those. Want to mark a pen and label, we want to be able to label these. Once we've made our ocean at home, we're going to keep them because we're going to keep using those oceans on all the other programs. So that's our kit. With our lab, we need to know what tools we're going to use or what method we're going to use to improve our precision and accuracy. Now, if we're talking about salinity, we're talking about a certain weight of salt. How much salt is in that water. Often it's recorded as grams per litre, but it is actually a ratio of parts per thousand. So let us see if we can work out how well we can measure 1 litre and then weigh it, because we are going to be weighing salt into it. You can just use the tier. On the sheet that goes with this, it actually helps you to record the container and the container weight. You will need container weight. And we're just going to accurately as we can, precise as we can, measure 1 litre. That means looking horizontally across the litre mark, and you're looking at the bottom of the meniscus. What does that weigh? We're getting 998 grams for my sample. Am I going to get that each time? Am I that accurate with this measurement? What do you think? Which is going to be more useful, weight or volume? Your task is to do this 3 times and then work out your precision using the guide sheets that are attached to these videos. We're talking about precision and accuracy. Here's a wee game you can do in your bubble inside. Indoor patrol. Dog nibbles and a cat. I'm going to try and get as near to that cat as possible. And very quickly I can see that I am not getting very near it. In fact, what's happening is that most of my attempts bounce out and are in this corner here. It's not accurate, there's a bias over this way. And it's not precise because they're so spread out. So precision is about how variable and how spread out my attempts are, and accuracy is about how on target my attempts are. I'm neither precise nor accurate here. RAF is both more accurate and more precise. There's less variation in the spread and they're more on target. We've worked out something about our precision, and it turns out, looking at my figures, that I can only really weigh a litre of water within a precision of 1,006 grams plus or minus 8.5. Whereas these scales here, they measure to 1 gram. They're going to be able to measure plus or minus a gram. How accurate I am will depend on how close my average is to the actual weight of a kilogram. Now, I'm sure you've already found this out, but a kilogram of water, a litre of water, is a kilogram of water. So if I get the weight of my container, and I know my container is 50 grams, so I'm just going to make a note of that, 50 grams for my container, and I tear the scales and I use weight as a way to measure my litre, and I try and get exactly 1,000 grams, spot on. Oh, went a little bit over. Oh well, here we go. Take that out, take that out. Yep, 1,000 grams. That's much more precise than me measuring with it. We've got already 35 grams of salt. 35 grams of salt already weighed out. I'm going to mix that into my 1 litre of water. I'm going to be making my ocean at 35 grams of salt per litre, or 35 parts per thousand. Mix it thoroughly, get it all dissolved. The water plus the salt dissolved in it weighs 1,035. We added 35 grams. Now, when we note this down, the water and salt by itself, 1,035, we can see that even though it's still a litre, even though it's still 1 litre, and I can show you that very quickly, and you can test it yourself very quickly, just simply by pouring it back into your litre container and just reading that very carefully. It's exactly the litre. Even though it's the litre, it weighs more. So weighing more in the same volume means it's more dense, and density is the next thing we really want to look at closely.